Okay, in this tutorial we're going to continue on a little bit with the previous one in which we're going to import another AutoCAD file. However, we're going to focus just a little bit more on the drive, inserting drives and pulleys and wrap angles and pulley types. So I went ahead and here's a more of a typical AutoCAD file you might get from your drafting department or whatnot. Just showing a simple conveyor. It's just got a single pulley at the tail. It's just a straight conveyor that comes up to the head, discharges onto another conveyor, and then there's a drive station partway down the conveyor. And this again shows some of the power of Sidewinder that we can put this conveyor in exactly how we see it here. So to start with, I could create a new layer or whatnot, but I'm actually just going to issue a P-line, just P-line command. And we're going to go ahead and start at the tail pulley here. And on this particular conveyor, we actually have an elevated head pulley. So I'm going to click to there and create two elements on our carry side. And now at this point I could actually just snap across here and you'd see I have this short little 1.5 meter, 1.4 meter flight, and then continue on back. And if I imported this into Sidewinder, we'd then just have a straight element here, at which point I could change that element into a pulley and so on and so forth. But kind of a nice addition we've added to Sidewinder is the ability to actually enter this pulley, and we can do so by simply typing arc. So we're in the P-line command and we type in arc, and now this creates an arc for us. And what Sidewinder does is it looks at our arcs, and if the arc is less than about 5 meters, it assumes that's now a pulley, and it's going to bring that in as a pulley. If we actually had a concave or a convex curve, we also could have used the P-line arc command, but in that case the arc probably would have been 100 meters or 50 meters or whatever our radius is, and it would have entered that in as two flights, an IP point, and actually put a curve in it. But if the radius is small, as in would be a pulley, then it assumes that it's a pulley. So we've created an arc. We then use L to go back to line and draw a line back to our beginning of our next pulley. We can use arc command again to create a little arc around that pulley. L back to a line, because as I say, we're just drawing a single polyline. Arc to go around this pulley. Line to go to that pulley. Arc to wrap around our drive. Line to bring it back. Arc again to wrap around our drive. Line to bring it back. Arc. Line. Arc. And I'm being a little bit sloppy here. I might not get it exactly right, but let's just show you how to go ahead and do this. Line. Arc. And we're basically done. Now I could go ahead and create a line. I will do this just right back to the tail pulley and just end it with that. So now we've got all kinds of stuff in this AutoCAD drawing, and if we brought this directly into Sidewinder, Sidewinder wouldn't know, is this the conveyor line, or is that the conveyor line, or is it small, wouldn't know which line or what actually is the conveyor. So if I click on this polyline that we created and I simply copy it, I'm going to then paste this in a new file. So I just create a new file and paste, and there's our polyline. So now we have a single file, single AutoCAD file with a single polyline consisting of all our pulleys and our whole conveyor arrangement. I now save that as a DFX file. Again, I'm going to just choose AutoCAD 2000 format. We'll call this profile. And that's it. It already exists. Sure, we'll overwrite that existing one. And now if we go into Sidewinder, create a new file. I could just start with an empty file, or I could have started with any one of those. It really doesn't matter because we'll overwrite all the flights. Import DFX. Go ahead and select our profile, and voila, there's our conveyor. Again, I drew that on a 1-to-1 scale. Oh, sorry, that was 1,000 to 1. And I can see that by the conveyor length should be roughly 375 meters. 100 meters of lift. And I click continue. And there we have it. We've just brought in our conveyor. It has about a 14-degree slope. Came up. We've got our head pulley here. We've got our nice little drive arrangement here. And we can see we're going to have to do a little bit of tweaking on this. Now, typically what I like to do, and let's see, this happened to be a drive. So now it doesn't, it brought in all the pulleys, but it wasn't sure what was drives and which were pulleys. So we still have to do a little bit of massaging here. So we're going to go ahead and make that was a drive. This was a drive. And this was our take-up. All the rest were simply pulleys. Now, the pulley type ID. Again, you might have 15 different pulleys on your conveyor, but there might only be 3 types. You might have a drive type, you might have a high tension type pulleys, you might have low tension type pulleys. So Sidewinder, in Sidewinder, you don't have to go through and specify all the details for every single pulley. You simply specify the details for each pulley type. So in this case, as a rule of thumb, I like to make my drive pulleys just type number 1, just by default. And we'll say my medium tension or my high tension pulleys, which would be this head pulley up here, because obviously that's going to be a high tension pulley. And the pulleys coming into the drive will all be high tension pulleys as well, so I'll make those pulley types 2. And now leaving the drive, I can make these pulley types 3. Okay, and you can see we've got a little bit of things we're going to have to massage here. And let's make our tail pulley. Oh, we haven't entered a tail pulley yet. If we go down to the bottom here, we'll insert one more flight, and at the bottom we'll add a final tail pulley. And just to show you, I'll make that a pulley type number 4, just to make it different. Now, we've entered these different pulley types, but what we haven't specified is the details about the pulleys themselves, what the pulley diameters are, and shaft diameters, and all that sort of information about each pulley. And how we do that is if we go back to our main input window here, I click on this main input window, and down under motors, reducer, brakes, pulleys. Here we go. Now you can see Sidewinder has automatically created 4 pulleys because we've got 4 pulley types. From the drawing, it brought the first pulley in, and it was 1450 was the radius or thereabout. I must have, if I didn't snap exactly on the radius, it might not have caught it exactly. That's why I got the 1401, and it assumes a 12 millimeter lagging thickness. But again, if that was slightly different, say it was 1450 or whatever, we can go ahead and enter that. So 1450 plus 10 millimeters of lagging would be a 1470 diameter pulley with the lagging. So we can go ahead and make those, whatever we want, 1500 or 1400. We'll say our high tension bend pulleys are also 1400, and we'll give them 10 millimeters of lagging. And then let's say our medium pulleys are 1200, and our low tension pulleys are maybe 1000. And again, I'll just make the lagging 10 millimeters thick. Now with our drives, if our drives happen to be ceramic legged pulleys, all we'd have to do is check that right there, and that would turn the drive into, it would use ceramic lagging. So when we calculate the belt tension ratios and that sort of stuff for that pulley, it would use the ceramic coefficient of friction rather than the rubber coefficient of friction. So that's pretty much all it is. If we go back to our main page here, go back to my geometry page here, hey, there's our layout. It's automatically updated all those pulley diameters for us. And if another shortcut again, and also you notice we haven't entered any of the wrap angles. It's automatically calculated all the wrap angles for us. I.e., if I change the elevation of this flight from 0.37 to 0.5, we will see that the wrap angle on this drive pulley has now increased to 193. If I just simply undo that, it was 190. So there's a distinct advantage of actually entering in all the wrap angles in your geometry correctly, because also when it goes to calculate the pulley and shaft forces and tension vectors on the shaft, it'll calculate all those correctly, and obviously add the pulley weight, which is always going to be a downward force. So it's essentially just very nice to do that. Now, in some cases, for whatever reason, if you wanted to say, okay, I don't want it to auto-calculate, you can always uncheck this auto-calculate button, and in which case I can now specify, I can say that this is really 210 degrees of wrap. I can make it whatever I want. Generally, we just don't recommend it. It's much better to simply enter your incoming and exiting flights correctly and have it calculate those values correctly. Another shortcut, again, just to reiterate, if we calculate or enter a positive number, it's going to assume that the wrap around that pulley is in the positive direction. If I enter a negative number, it's going to assume that that wrap is in the negative direction. If you ever forget that, you can simply right-click on the wrap as well and simply say, okay, auto-calculate clockwise direction. Auto-calculate clockwise direction. This would be counterclockwise direction, and so on and so forth. Another shortcut that we've added is simply entering the pulley diameters. As I just had mentioned, we can go over to our main menu and under the pulleys and enter our pulley diameter right here. However, sometimes it's just sort of nice to be able to do that right in the profile itself. So if I right click, I can say specify pulley diameter. You see it automatically defaults with the value we had entered of 1410. Maybe I want to change these to 1500s and 15 millimeters of lagging. Go ahead and click OK, and you can see that those automatically just change size. Or maybe I want to make them 1015. Again, you can see that change size, and of course if we go over here, it also changed it there. It's the exact same whether we enter it here or we just right click and enter it right there. It's just a shortcut way to do it. Back and say 1500 here. Okay. Now we haven't entered any of the other information into this conveyor. I'm just going to go ahead and run the calculations. Normally, obviously, we'd have to enter tonnages and belt information and whatnot. But at this point, I just wanted to show that we can also, once we've got the design narrowed down a little bit, Sidewinder will come back and give you a required diameter as well. For the belt that this happened to select, let's see, it picked an EP 1800 3-ply. For that, we needed a high tension pulley. It automatically specified whether these were going to be high tensions or low tensions based on the tensions. We also could have just physically specified that, hey, the drives and that first pulley set are going to be high tensions. Maybe these we want to be classified as medium tensions, and that tail pulley we're going to go ahead and force that to be a low tension pulley, or we could also say a snub pulley. And all that essentially does is it comes back and it just says, hey, these are what your required diameters for you. And in fact, in this case, it said, hey, we've currently got, what did we must have entered something wrong. Oh, we entered a diameter of 100 millimeters for a pulley diameter, which is obviously silly for the tail pulley, and it came up and highlighted that red saying, hey, that needs to be at least a 650. So go ahead and put 650 in there, run that. Okay, now everything's okay. So that's it in a nutshell as far as just bringing in a drive arrangement directly from AutoCAD and looking at just what the wrap angle and the pulley type ID is in the profile.